Hey guys, welcome back to our next lesson. Today we're going to be talking about transformations. So in this new unit we're studying, we're all diving into coordinate pairs and graphs and things like that. A transformation, you're probably used to the word transform. To transform means to change something. And we're basically going to be studying some rules that will alter a point and do something to it. But we're going to look at shapes because it's easier to see a whole entire shape and how it changes than like one single point. Okay? Our mindset message today is to find the beauty in math. I think graphs are really important because they give us a visual of a relationship that's happening, and you wouldn't have that otherwise if all you were looking at was like a rule with variables or something like that. So there's a lot of beauty I find in these topics. Our learning goals today, first off, to apply transformations to ordered pairs and figures, and describe the effect of a transformation rule. So I'd like you to be able to look at a rule that we're going to learn, you'll see what I mean, and be able to tell what it's going to do to a figure or to an ordered pair. Our prior knowledge basically is just plotting ordered pairs as points in the coordinate plane. That's the basic thing you need to know most importantly for this lesson. So for example, the coordinate pair, the ordered pair, -2, 3, would be plotted here. So if you remember, the x-coordinate comes first, followed by the y-coordinate. So if I start here at the origin, right, at the beginning, and -2, I travel on the x to here, and then I travel up 3 on the y. And so there's that location in the two-dimensional plane. So let's go ahead and dive into our first example and look right away at a transformation. Okay, so our first thing we're going to do is an example. This says, what happens to the triangle CAT, if we replace all of its points, x, y, with x plus 2, comma, y? So we're going to learn what we mean by this. Over here is where I have the triangle, so you should copy this down on your graph paper. So C is at -4, 0, A is at 10, 4, and then T is at -2, comma, -8. And if you connect that, this triangle has an infinite number of points all along the lines that connect it. But the points that matter most for this triangle to really form its shape are its corner points, right? We call each one a vertex, okay? So each of these corner points, each vertex is what determines the shape, because the rest of it is just in a straight line. So we're going to focus on those 3 points only. And luckily for most shapes that we'll look at, that's what we need to do. So here's how we'll look at this. Let's go ahead and put x, y here, and then x plus 2y here, and we'll kind of make a table and look how they become one versus the other. So let's list these points out. -4, 0, 10, 4, and then -2, -8. Now typically, I'm going to share with you, we usually put a little arrow here with kind of a line on it to actually represent a rule, a transformation rule. So actually, this right here would be the rule that we're working under. Now, if this was my point, then this rule says, do we do anything to the y-coordinate? Nope, because it just stayed y. But the x says to add 2. So for all these x-coordinates, we're going to add 2. So it becomes -2, and that stays 0. If we add 2, this becomes 12, and the y-coordinate stays. And then this -2, if I add 2, becomes 0, and then again, the y-coordinate stays. So we'll use this arrow to show that this became that, this became that, and this became that under our new rule. Now before you actually plot it, and I'll have you plot it, I want you to just take a careful look at these coordinates and ask yourself, how is that triangle going to change after we did this? So if you guessed that the triangle was going to shift to the right, then you are correct. So take a look at the new triangle here when you plot the coordinates. It has simply been moved to the right by 2 units. And that would make sense because look, what did we alter? The x or the y coordinate? We altered the x. And since we just added 2, all the points just stepped over by 2. So the whole figure just stepped over by 2 to the right. Now, you can think, what would happen if I subtracted? Or what if I added or subtracted to the y? The x goes with horizontal movement. The y goes with vertical movement, right? One last thing to mention. For our original points, CAT on the first one, and I'll draw these in here as well. After we've transformed a point, the matching point, the one that it came from, right, or the one that this goes to, we're going to also call it CAT, because then we can connect and make sure we know which one went where. But we're going to put a little dash here, and I also color-coded it. And this dash we call prime. And in math, a lot of time, and I don't know the history of this, but we choose to represent if something changed, and then here's what it is after, we often use that prime notation. Okay? So there's the new one. Now let's take a look at another transformation rule, and I want you to do it on your own. So example 2 is very similar instructions, but if you'll notice, we're replacing all points with this new rule. X is staying the same, comma, 2y. So instead of adding or subtracting, we're now thinking, what if I multiply a number onto it? Okay? So please pause the video right now yourself, and then we'll come together and take a look at the new coordinates, and then make sure you sketch the graph, and try to think in your head, what do I think is going to happen? And then we'll talk about it. So let's check what you got here. So my new C prime, A prime, T prime now, okay? Notice the x coordinates stay the same, and then all these numbers double. And it's interesting that when you double 0, it just stays at 0. Now, whether you predicted it or not, it's okay, let's take a look. If you look at this green triangle now, notice how the width hasn't changed. It stayed exactly as wide. What ended up happening is it's been stretched out. So it's actually now twice as high as it was. And if you actually counted the height of this triangle, so if we went from this highest point down to this lowest point, in the red one, and then you went from the highest down to the y of the lowest one, you'd see that that height got doubled, okay? So we say we stretched it by a factor of 2. Now let's put some of this together and have you think about some more of these ideas before we wrap up. Okay, now it's officially time for a vocab word, and this is an important one you need to make sure that you have down. A rule that takes a set of points and produces another set of points is called a transformation. And transformation rules always look something like this for now. Now there's other ways we actually put them later on, but as we're learning it right now, this is the basic way we represent transforming points. So I want you again to do this one on your own. It says predict how the set of points would change for each transformation rule. So you're not going to actually physically do these on some points like we did in our previous examples. I want you to actually just think and write down how you think each of these rules is going to change a figure. So you can imagine that triangle that we had or any other figure that you have with points. So please pause the video now and write down your predictions, and then we'll check our answers. All right, let's go ahead and assess and see how you did. So this rule adds 2 to y. We know that's a vertical change we're making because it's changing y. And that means and since it's adding, it's a shift, right? So the whole figure would just shift up 2. This one, since it's x and it's minus, the negative direction for x goes left, right? So it would shift everything left 5. This one has 2 shifts. You're going to shift to the right 3 and down 10. This one, this is a stretch again because we're multiplying, right? But instead of stretching vertically, we aren't changing vertical at all. We're just going to take it and stretch it horizontally, so it's 3 times wider. This one may have been a little weird for you because you might want to call it a stretch, but since we're multiplying by 1/2, multiplying by 1/2 actually shrinks something, I guess you could say. And we call that in math, we call that a compression. So instead of using the word stretch, the opposite of that would be compress. So it's going to compress vertically, and essentially it's going to now be half of the height that it was. And then, very last, notice that we have exactly the same factor multiplied on both the coordinates. Essentially, this basically perfectly enlarges it. It's both horizontal and vertical by the same factor, so it's as if you just zoomed in twice as far. All right, so our next vocabulary word is as follows. The x and y axes divide the coordinate plane into 4 parts, and they're called quadrants. Quad stands for 4, right? So they're called quadrants. And this is a pretty common term in many uses. This is quadrant 1, that's quadrant 2, we call this quadrant 3, and that 4. And it's weird because we're used to naming things like left to right and top to bottom, right? So you may be thinking that we should name it a different way. A little bit of the history. This naming system and this way of moving around started a long time ago when people would watch the stars at night, because they noticed the stars would move in a circular motion, but the stars move from east to west, and then they go around the world like that. So that's why these are named in that same way. So this is quadrant 1, 2, 3, and 4, and we start over here. So something I want you to just do real quick, write coordinates for a point in each quadrant, and then there's something I want to talk about those points. So you can just pause and do that yourself really quick. Okay, well, there's a whole lot of options, so I can't just tell you there's one correct answer, right? You could put a point in many places and be in these quadrants, right? So these are just random examples of things that I just pulled out. So this one is at 5, 5, so I'll just put that example there. This one's at -2, 10. This one's at -6, -2. And then the one in 4, I put it at 1, -1. Now, why I want us to think about this, and maybe this was just something you found, simple or whatever, is because there's actually something really important about points that are in each quadrant. One thing to mention, sometimes students, they don't know what to do if it's on the actual axis. Interesting thing, if it's actually on the x-axis or on the y-axis, we don't say it's in any of the quadrants. It's kind of just on the axis. Something true about every coordinate pair over here, if you notice our point or the point you chose, is that the x-coordinate is always positive and so is the y-coordinate. And we can say something like that about every other quadrant here. So this one is, x is all negative, but the y's are positive. In quadrant 3, both the x and the y are negative. And then in quadrant 4, the x is back to being positive again, but the y is still negative. So those are some important things to remember about this. Let's take a look at one last thing, and then we'll be through today. So we have a rectangle, we're calling it ABCD. And here's 2 things I want you to do. Fill in the missing coordinates. Now, I want you to try to do this without actually just counting them out. Look at the coordinates that are given to you, and then the fact that you know it's a rectangle, try to finish filling in the empty spaces. Here, 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 and here. And after you do that, think about the movement of this, and I want you to write a transformation rule that moves the rectangle and places it entirely in quadrant 3. And remember, that's down here. Okay? So pause now and do that, and then we'll take a look at answers. All right, let's take a look here. First, fill in the missing coordinates. So, like I said, instead of just counting, try to use what's given. Well, we know this is at a height of 4, and if that's a rectangle, that must also have a height of 4, so we should have a y-coordinate of 4. And same with these should have the same x-coordinate as each other. If that's 6, that must be 6. And then same here, these should have the same x, and then across here, they should have the same y. And the next thing and the last thing, write a transformation rule that places it in quadrant 3. You'll notice we don't need to do any stretching or anything or compressing. All we need to do is shift it, but we need to shift this left and also down. Well, since this is here at 6, I have to at least go back 6, but I need to go at least back 1 more. So if I go left by 7, and then this needs to go down 4, it needs to go down at least 5. So if I go left 7 and down 5, or any more than that, then it would be a correct answer. So you do need to have something that shifts it left and shifts it down, so subtracting, and it needs to be at least 7 and at least 5. So that's it for today's lesson. Happy math, and we'll see you guys in the next lesson.